Okay, shh. Stop. So that's why you should keep your phone locked and not tell people your password. Or not use Snapchat. Number one, when you take this test on Monday, which is the next day that I see you, we're taking a test. When I look at number one, the very first thing that I see is it's a closed domain. X squared of 2 minus x is a continuous function, which means right away I know that the extreme value theorem applies. It never tells me, hey, you should check to see if the extreme value theorem applies. You have to know this. Oh, it's a closed domain, so which means 100% that there's going to be a max and there's going to be a min because I have to check negative 2 and 2 plus any critical point. So think about that as you're doing these problems. Then I got to find the derivative. So if I find the derivative, I'm going to do the product rule, because that's 2 minus x to the 1/2, and I'm going to get 1 times 2 minus x to the 1/2, plus, leave the x alone, and then this is 2 minus x to the negative 1/2. Oh, look, I forgot to pull the 1/2 out front, so I'm just going to throw it there. Right, pull out the 1/2 in front, but I forgot.
We can also pull a negative out.
And then I have to take the derivative of the inside, which is a negative 1. Right, I can fix this if you want. I can put my 1/2 there.
I did that.
But don't forget to multiply by the negative 1. Yesterday we did this one in CalcLab, and we discovered the mistake for most people was they forgot the negative 1. And then it becomes, can you simplify this? And you always have two options. One option is you could rewrite this and get a common denominator. But the other option is that crazy factoring that I showed you in this chapter, that if I see the same term, 1 to a positive exponent and a negative exponent, I know every time, if I'm trying to get this equal to 0, I'm going to pull out the 2 minus x to the negative exponent. Because when I pull out the negative exponent and I take this minus this, I always get to the first power, and it works out really nice. So if I take 1/2 minus negative 1/2, I just get 2 minus x to the first power. And then over here, I took out that whole negative exponent. So this whole thing is gone, and I'm left with negative x times 1/2, which will be negative 1/2 x, or negative x over 2. That's a minus sign. I don't know why I put brackets instead of parentheses, but I'm going to turn on my cooling system.
We did this problem like 4 times, so we kept putting x minus 2 instead of 2 minus x.
This is supposed to, in lieu of opening it up. Yes. Think about when you do this. X cubed minus x squared. You don't add, you subtract, but you're subtracting a negative, right? When you take out x squared, how do you get what's left? You take 3 minus 2, right? So the same thing on this. When I take out, if I had x to the 1/2 plus x to the negative 1/2, if I take out an x to the negative 1/2, how do I get to what's left? I subtract. And 1/2 minus negative 1/2 is why it turns into adding, because you're subtracting a negative. So you should always get a 1 when you do the crazy factoring. If you try to do crazy factoring and you don't get an exponent of 1, either you've done it wrong or it's not a crazy factoring problem, because the idea of the factoring is what's left is easy to work with, as opposed to the rational exponents. If you got a common denominator, you should get the exact same thing on the top, and then your denominator is on the bottom. Or maybe I think there's a 2 on the bottom too. But it ends up with the same answer. But I just feel like this shows up a lot in our class on the AP exam, and so I like to try to push it on you to do here. And if I set this as equal to 0, I would have, again, I'm going to get a common denominator here, and that would become 2x over 2. So I would get 2 minus 3x over 2. And then I could subtract 2 over, and then I could multiply by the reciprocal, which is negative 2/3. And that's how the back of the book got a critical point at 4/3, which is the exact same answer you get if you got a common denominator. And also you might say, well, I need to look where this equals 0, because this is going to be undefined because it's in the bottom. And it's true. If you say, where is this equals 0, you get x equals 2. But I'm already checking x equals 2 because my domain was closed and that's my endpoint. And so, kind of the same number twice, so it's up to you on if you actually do it, if you realize. But isn't critical points where it equals 0 and where it's undefined? Yes. This is what I would have, right? But I have to say, where is that undefined, right? It never equals 0, but I have to say that it's undefined there because critical points are where it equals 0 or where it's undefined. And if you get a point that it's undefined in the derivative, but it's not undefined up here, which 2 is not undefined in the original problem, because you can't have the square root of 0. You just can't have the square root of 0 on the bottom. Right, which is what it doesn't equal 0, but it's undefined at 0, and you have to think about those points also. It's both. I'm so confused. Yes, it never equals 0. I agree with that statement. Does this equal 0? No. But the definition of a critical point is where does my derivative equal 0 and where is my derivative undefined?
No, I understand that. I just meant because you got it for 2 doesn't equal x equals 2. But I got
That's my undefined point, though. That has nothing to do with the solution to the equation. That's not the solution to the equation. There is no solution to the equation because you're right. You end up with 1 equals 0. It's not a solution. But I looked at this and said, oh, it's in the bottom. What's going to make that undefined? So I'm saying that this is an undefined value. But it's that an undefined value is a critical point. Here's the other great thing about extreme value theorem. I don't even have to do the first derivative test on this because if it's extreme value theorem, just like we did back in 4.1, I can say I know the biggest number is the maximum and the smallest number is the minimum, which means I can actually just plug in -2, I can plug in 2, and I can plug in 4/3. If you want to do you can do the first derivative test, but you still got to check the endpoints. So it's where you have to think about when does the extreme value theorem apply. I plugged it into the original problem, and again, without a calculator, it's kind of hard to get the 4/3 value, but the 2 and the -2 you can plug in, and if you plug in -2, I think you should get -4, because you get -2 times 2, and when you plug 2 in there, you get 0. And if you didn't have a calculator, when you plug 4/3 in there, you get a positive number, which means it's bigger than this and bigger than this. So even if you didn't know without a calculator how could I actually figure out what it is, you could figure out that it's going to give me a positive number, which means it is going to be the maximum of it. But since you had a calculator, I just plugged in my calculator and got like 1.09-ish. Because extreme value theorem applies, I can say for sure that this is the maximum, not just a relative maximum, and I can say this is the smallest value, and I can say that that is the minimum for sure. I know this question asks you a bunch of things. That's what's kind of defeating about the beginning of this review, which is why hopefully tonight you're going to go back and finish it. But we just answered part, oh no, it just says finally goal extreme values. Just kidding. The next one is going to have like part 8. What? I started number 10 when I was picking this assignment out, and I spent this much paper on it, and it was just a big giant mess, and I scribbled it out. And then I picked number 15 for you to do. Michaela, any questions? Because you picked where it was undefined, right? That's why you had 2. But you have to remember, if it's a closed domain, you have to use the extreme value theorem. So if the domain is closed, you have to check the endpoints. And again, that's a free response question every year that they give you something with a closed domain and they want you to find the max and min. And even if the max ends up being the extreme point, like there's a point in between there that you have to show what possible points there are. And they want you to say, well, I need to check the endpoints and I need to check my critical points. And if you don't tell them you know to check your endpoints, then you lose a point. on that problem. Because they want you to know if it's a closed domain, so you have to check it. So I'm gonna skip number 6 right now, but if you have number 6 done, or you have questions on number 6, see me, but I want you to try that. We've done a lot with E, so go back and find a similar problem. I want to look at 15 for a minute. I don't know if I want to do all of 15, but it is kind of a big mess. In 5th hour yesterday, they said, is there going to be one as terrible as 15 on your test? And I would say probably not. Is there going to be one that you have to maybe do some crazy factoring and get a common denominator on? Probably. But 15, the second derivative gets really ugly, and it just takes a lot of time to do all that. 6 wasn't bad for me. Like 6 I did in this much paper, even doing parts A through F, because it wasn't that bad with E. It's not bad to do first, second derivatives with E. That's why I like E. 15 I used this whole sheet of paper to do 15 on my paper. Well, I like to be able to read my work and follow what I'm doing, so that when I'm helping someone, I can see what's happening. But definitely we want to be able to find the derivative on this. I do want to say to think about options that you have here. Yesterday in 5th hour, they said they did the product rule, which is okay, we can do the product rule, but I want you to be aware of when you can make your problem easier on yourself. Since there's no exponent out here, could you have distributed that x to the 4/5 first and made a problem that you didn't have to do the product rule on? If you wanted to. I can do the product rule if that's what you've done, but I'm just saying that I did that on my paper because then I didn't have to do the product rule and worry about just simplifying even more stuff. So just be aware of that. If there was like a 3 out here, you can't just distribute, but you could just distribute that, okay? Because you can add those exponents, right?
So if you didn't really ever want to do the product rule, say that was cube, you could boil it all.
You
out.
could. Would it be smart to have to FOIL out something that's cubed or to the 7th power?
If you weren't comfortable with the power rule and you don't figure it right that way.
But think about your time issue, right? Like that's the issue. Is tests are timed, the AP test is timed. AP multiple choice is about 2 minutes a question. If you add something to like the 7th power, it's going to take you more than 2 minutes just to FOIL that out, and then their answer is not, their multiple choice answer is only going to be that feasible. But you're right. You could always just multiply it out. Or some on the calculator portion of the test, which they would never give you one like this. Some calculators can do that for you. They can expand those things. So product rule or not product rule? How about I'll do both ways since I got both answers. But I did this. I did 2x to the 4/5 minus, if I add, that's 5/5 plus 4/5 is x to the 9/5. That's distributing, and then I'll do the rule. I'll do both derivatives, okay, so that whichever way you did it. If I distribute, now I can say that that's 2 times 4/5, which is really just 8/5. And if I subtract 1 from this, I get x to the negative 1/5 minus 9/5. And if I subtract 1 from that, 9/5 minus 5/5 is 4/5. You get the exact same answer if you do the product rule, you just have parentheses that you have to deal with. So if I did the derivative with the product rule, I would say that's 4/5 x to the negative 1/5, leave the inside alone, plus leave the x to the 4/5, and the derivative of 2 minus x is just negative 1. And if we distribute, we're going to end up with the same thing. You're going to be able to combine like terms, and you're going to get exactly this. I just think if you can distribute, I think it's easier to do that problem. And again, you have options. We could move that x to the 1/5 down, and we could make the common denominator be 5x to the 1/5. We also could pull out an x to the negative 1/5 because I think the little factoring way would work as well. Here's how you know if the factoring way works. If I take this exponent minus this exponent, does it work out to be a nice whole number? 4/5 minus negative 1/5 is really 5/5, which is really 1. Yes? That's how you can decide, should I do crazy factoring? I didn't on this one. I got a common denominator. But do you want me to show you the common denominator, or do you want to do the factoring way? Crazy factoring. Which means we probably could pull out like a 1/5 x to the negative 1/5 if you want. Do you want to pull the fraction out too, or leave the fraction?
Did you pull out?
Well, if we pull out a number, it's like we're dividing. So we'd have to just take 9/5 divided by 8/5. I don't really want to take it.
I just take the X.
Leave the fifths.
So take the one.
I think take the. Do you agree?
That's what I mean, yeah, take the.
Like I think if we're gonna factor it out, it's easy to take out the 1/5 and the x to the negative 1/5, so that what's left is not a fraction, and I don't have any crazy exponents anymore. Because if I take the 1/5 out, I'm just left with 8. I took this out. Minus, I took the 1/5 out, so I'm left with 9. And again, 4/5 minus negative 1/5 just gives me x. That's why I should call it cool factoring and not crazy factoring, so maybe you're not scared of it. But it's really cool. Like, Jake, was it you that said you felt like you've never done this much algebra and algebra before that we've been doing? I think, who said that? You didn't say that? Someone said that.
I agree.
That, this is algebra. It's algebra rules you've been doing, but you're having to think a lot more and probably do a more algebra than you did in algebra class. But if you get this, now very easily I can say, my critical points are where does this equal 0, which I just do in my head. I'm going to subtract 8 and divide by negative 9, which gives me a critical value of 8/9. But also, I have to think about where my derivative is undefined, and that's this part. I'm not actually going to set the problem up because I know it's not going to equal 0, but if I have an x to the 1/5 in the bottom, do you agree that x equals 0 has to be a critical point because it's undefined in my derivative? So I actually get 2 critical points. And so this problem actually asks you to find not only relative max and relative mins, but they ask you to find where it's increasing and decreasing. So to me, it makes sense that we would do the first derivative test, because if I do the first derivative test, when I plug it in, I'm going to get my answer. I'm going to get answers to parts A, B, and E, right? A, B, and E, I'm going to get the answers to by just doing this first derivative test. So I'm going to be able to tell you where it's increasing, where it's decreasing, and any local extreme values. We plug this back into our derivative, which is also where it's helpful if you have it factored, because you can just think about positives and negatives. If I plug in a negative value here, like negative 1, this is on the bottom, right? Maybe it's helpful if we write that as 1/5 x to the 1/5. Right, that's really on the bottom there, so you don't get confused by the negative. If I plug a negative 1 into x to the 1/5, what do I get out of that? What is negative 1 to the 1/5 power? Negative 1, because it's an odd root, right? Like, it's like the 5th root of negative 1 is really negative 1. So I get a negative out here, so I'm going to just say negative. And then if I plug negative 1 in here, do you agree that that's going to end up being a positive? That's going to become 8 plus 9, which means a negative times a positive is negative, which means that the function is decreasing. Let's pick this side now. Bigger than 8/9 is easy, right? Like, I'm going to just pick 1. And if I plug 1 into my derivative, 1 to any power is 1. So I'm going to get a positive out there with the 1/5. And then if I plug 1 in here, I'm going to get 8 minus 9, which is negative. Yes? Which is still negative. Which means I have to pick a number between 0 and 8/9. We could pick, I don't know what you want to pick, 1/2, 1/4. There's not really a lot of nice numbers going on here. But we're looking for signs, positives and negatives. So if I just pick 1/2, I don't care what the 5th root of 1/2 is, but do you agree that it's a positive number out there? So it's a positive, and if I plug 1/2 in here, I'm going to get 8 minus 9/2, or 8 minus 4.5, which is a positive number, which is a positive. Which means I can answer parts A and B. My function is decreasing from negative infinity up to 0, and from 8/9 to infinity. And my function is increasing from the interval from 0 to 8/9. And again, I don't know if you checked in the back of the book, but do they use brackets on this? They use brackets. I always use parentheses, so it's okay. But it doesn't. It really doesn't matter. What matters is if you mixed up and half the intervals you did like half bracket, half parentheses, that's an issue. But as long as you use all brackets or you use all parentheses, it's okay. But you can't bracket infinite. Sorry, you're right. I just mean the numbers. Right. Yes. Sorry. I guess I should have been better. So you still have the parentheses around the brackets, but I just use parentheses because for me, I feel like again, there's two sides of the fence in this. Like either people say it should be brackets, or like my side of the fence, I say it should be parentheses because at 0 it's actually 0, and I say it shouldn't be increasing or decreasing there. But it seems like the AP test used brackets, so maybe I need to jump on that side of the
I
fence.
thought whenever you were naming like X interval, like I was like, because you're not really naming the points, so it's not like.
Right, but you are including the number on the x-axis in that interval when you use brackets. But it's okay. I'm okay. We can use brackets. I'm okay with it. But also I can say for part E that this was decreasing to increasing, increasing to decreasing. So I can say for part E that there is a relative minimum at 0 and a relative maximum at 8/9. And to actually find the value that goes with it, you have to plug it back in. I'm not actually writing all this out for you because I'm leaving it for you to do. But I do want to look at the second derivative really quick on this before we move on if you want to look at something else. Because there's a whole lot of other stuff on this review. Again, not a huge deal because there are not any as ugly as the second derivative on your test as this. But to do the second derivative of this, you can go here and not have to do the product rule. Do you agree with that? I think that's the best option. I'm going to erase this if you're okay with that. If my eraser will work. And so I'm going to use that as my first derivative to find my second derivative. So I'm going to get 8/5 times negative 1/5 is going to be negative 8/25. And then if I subtract 1 again from that, is that going to be negative 6/5? Do you agree with that? And then if I bring the 4/5 down, 9/5 times 4/5, you just multiply top and bottom. So I think I get minus 36/25. And again, if I subtract 1, that's going to give me x to the negative 1/5. Yeah, so can I do the same thing that I did before? Only what would I factor? Would it work? What would I factor? Which exponent would I factor out? The negative 6/5 or the negative 1/5?
Then would you get negative 5 to the 6/5, so it would be negative 1.
If I take out the negative 6/5, this will be gone, and this would be negative 1/5 minus negative 6/5, right? Isn't that just 1? Yes? Telling you, if we don't learn derivatives, we at least learn how to do fractions in calculus class. Like, you know, like, I know, I'm not saying you don't know derivatives. I'm just saying, I feel like, if I feel like you don't learn calculus, I feel like you at least have to learn some fractions. Can I pull out the 1/25 like I did in the last one too? Like, I'm going to do this, 1/25. So I get negative 8 minus 30. Oh, yeah, it's right. Well, I didn't, but you're right. It'll work out the same way. Either way, we're going to get the same answer. That's way better. I did this awful quotient rule. This is way less work than what I did in my paper. There's a lot of ways to do this. If you can still get the same answer, I'm still going to get that it's undefined at 0, right? Because of this negative 6/5. X equals 0 is a possible inflection point. And then if I solve this, I'm going to get negative 2/9. That's not so nice. Good thing is you have to graph this. And again, if I'm trying to find concavity and points of inflection, I'm going to do the exact same thing I just did, only now I'm going to do 0 and 2/9, and I'm going to leave you to finish that you're going to plug it in, and I will tell you both of these end up being points of inflection, which means if you, oh no, just kidding, they don't both end up being points of inflection. One of them ends up being a point of inflection.
2 nines, probably.
19 and 20, antiderivatives. There will be antiderivatives on your test. And when it says find all possible functions, remember that's where you have to do the plus C. If they give you, like, did I give you 23 or 24? If they give you a point, then you do your antiderivative and then you plug your point in, right? So, like 19 says, 19, goodness gracious. That looks kind of scary, doesn't it? The thing is, we haven't really talked about rules for antiderivatives. And just like there's rules for derivatives, like shortcuts, there are rules for antiderivatives, but we don't talk about them until chapter 5. And so right now, they just want to give you ones that make you think, what would the original function be in order to get this? And so think about when we take a derivative, we always subtract 1 from the exponent. So if I'm going backwards, remember that you have to add 1 to the exponent. So if I add 1 to -5, you agree that that had to be -4? And then you have to think about, sometimes it works out perfectly, but then just think, if I took the derivative of this, Emily, if I took the derivative of -4, x to the -4, what would the derivative have been? -4x to the -5, right? This doesn't have the -4 up here. So what has to be in front of this that would make this be a 1? Does that make sense?
Yeah.
Same.
Can you write -4 over x?
Oh my gosh. Is that allowed?
-4?
-4 over x.
No, the 4 has to be in the bottom.
I like it. Because then,
If you write
then you
this,
pull that out and that's 4 over x.
if you write this, right? This is what you're saying?
Yes. That's
No, because the derivative of this, you would write this,
yeah.
right? That would not cancel out. You have to do what we canceled out. And then the e one you have to think about also, but the derivative of e is e, right? The derivative of e to the x is e to the x. So definitely, if I'm going backwards on this one, I have to have the e to the -x here, because it's the derivative of e to the u is e to the u times u prime. But again, think about, if I took the derivative of e to the -x, what would I get? I would get e to the -x times -1, right? But that's a plus sign, so what has to be here so that that's going to change to a plus sign? A minus. Don't forget to add c. And the only other thing I can make you do on that is if I gave you a point, like number 23, if they say find the function that goes through this point, then you just plug in x and y and you solve for c. Hopefully those will be the nice questions on your test, right?
Sign is y, right?
What?
Sign is y, right?
Sign is y.
Y.
Other questions? I do. Colin?
Huh?
Like you had something to say.
I just didn't know what he was talking about, sign is y.
I always get sign.
I don't know why he's talking about sign either. Emily?
Well,
He's on
because
the, on the,
I'm talking about 23. Yeah, on the pink circle.
Oh,
I can't remember the sign and y for x. I always
that's
get-
terrible thing.
I couldn't mix it up. I can't sign.
Emily.
It's so easy. I know it's simple, but I can't ever remember.
Okay, when you think of it
Like I always think it's y, but then I always
So 32, they give you that graph.
you know that's wrong.
See, I still use triangles. I don't even think about it now. See, I always think it's simple.
That's fine. Just remember that sine of pi half is 1, and then remember that like 1 is up on the right corner.
Just can't do it except for one or y.
Oh my gosh, stop talking about trick for a minute.
23.
32 says, at which of the 5 points on the graph shown here are y and y prime and y double prime both negative. That's just checking that you know what that means, right? What does it mean if y prime is negative? It's decreasing, and what does it mean if y double prime is negative? Concave down. So it's just asking you at which of the 5 points, which I tried to put in the same spot, at which points is it decreasing and concave down? So looking at P, is P decreasing and concave down? No, it's concave up. Q, still, I would say that's like a point of inflection almost, maybe, right? No. Concave down and decreasing R. R is increasing. Nah. Decreasing and concave down. I think the answer to 32 is T only.
It says concave down, but technically like the line above.
That's the definition of concave down. The tangent line's above it.
I guarantee it.
I really don't want this class to end.
Because you have English test.
Yeah, I really. I have to go to the bathroom. I don't mind with the content, but English sucks.
38.
Wait,
Make,
is 32 B is strong?
32's T. We just went over.
No.
oh, part B. Where is y prime negative and y double prime positive? That means where is it decreasing and concave up? Decreasing and concave up is P. The only other place it's decreasing is T, and we already said that's concave down. So the answer to part B is P. Make sure that you look at 38. I can help you on Monday before school if we want to come in early. But 38 describes the motion. That's the one I did on the board back there. Probably a good chance you're going to have a question like 38 talking about relating velocity and acceleration to the motion of a particle on your test. So make sure you look over that one. Also remember that all of your homework is due on Monday. We also didn't talk about mean value theorem, but it is on that review. Number 37 is a mean value theorem question. So make sure that you look at that. 37 is kind of crazy. The end of 37 is crazy, but A and B on 37 is not crazy. Monday. No more review. Do you want more review? Okay.
Emily's like, I'm not even kidding.
I'll find something today and I could have run around and put on Harmony, but I'll have it also today. And so I'll either like come hunt you down. I'll just stand out there and do something. Yeah. I'll find something. I'll make something or